Patterns Physics students, hey, Mr. Trimble here. Let's talk about wave basics. I want you to turn to the next page in your notebook or pull out any piece of paper and let's just take some notes today. I'm going to keep this quick and simple. Let's start with the word wave. Now, I know you've heard the word wave in your life. There's waves all around you. Most of us have encountered waves either down at the Columbia River or out in the ocean. A wave is nothing more than the transport of energy without the transport of matter. And now this is really important because a wave is not actually a thing itself. A wave is just the movement of energy through something else. All right, so let's imagine you go out in your backyard. In fact, I encourage you to do this. Take a jump rope or a string, you tie it to the tree and you hold the other end. Now you're going to stand there and you pull that thing nice and tight. And now if you start to wiggle your hand up and down, you can create a wave that will move across that string. Many folks have done this with a slinky when they were a kid. Now here's the key, is that the wave travels in a specific direction. In this case, it would travel away from your body, off to the right, and then it would hit the tree, and depending on how it worked out, it could actually reflect back at you. So let's break that up and talk about the parts of a wave. We're going to start with a center line or a baseline, and this is going to be two complete wave sets. All right, so the first thing we're going to talk about is that every wave has a certain height to it. This is what we call the amplitude. Now, if this is moving too quickly for you, you are welcome to pause the video at any point to catch up on your notes. The amplitude is a height of a wave. In the ocean, big amplitude waves, surfers like to go out and surf down those large amplitude waves. If this was a sound wave, the amplitude would represent how loud that wave is. In our particular case with a string, that is how high a particle is displaced or how high the string is displaced at any point. The amplitude is measured from the center line up to the crest, which is the top of the wave, or down to a trough, which is the bottom of a wave. Notice, though, that the amplitude is only halfway between the crest and the trough. All right, our second drawing here is going to be about wavelength. And I'm sorry, this got cut off a little bit in the video. A wavelength is just how long one complete wave is from start to finish. You can measure that from crest to crest. You can measure that from trough to trough. It's got to be one complete wave. And we draw that with the Greek letter lambda. There it says lambda equals wavelength. Now that letter can scare some people sometimes, but don't worry. It's just an ancient letter that we use so we can't get confused. Now here's another little picture that is one wavelength. That could be from a center point down through a trough, up to a crest, and then down to another center point again. Either way here, we have wavelength, amplitude, crest, and trough. Anytime you make a wave, anytime you see a wave, those are the four things that you can easily identify. Now, wavelength is measured from crest to crest or from trough to trough. Now, here's something really cool, guys. Every wave must be moving in order to be a wave, and every wave has a speed or a velocity. The wave velocity is how fast a wave travels. Now, you guys know how to do speed. It's just distance divided by time. Now, when we roll marbles or balls across the room or roll a cart, we can always look at its distance and time. When your car moves down the road, we measure that in miles per hour. Now, sound waves and light waves can both be described as waves, but of course, sound travels much slower than light waves. In fact, it's significantly slower. Now, one thing to remember here is that wave speed is equal to the wavelength multiplied by the frequency. Now, frequency is a new word that I'm putting in here, so let's define it. Frequency. All right. This is nothing more than the number of complete waves passing by a certain location in 1 second. That is the frequency. It is measured in a unit called Hertz, which we draw with a capital H and a lowercase z. That is named after Heinrich Hertz. It's a person who came up with this particular concept. So Hertz can be a confusing word, but it's just someone's last name. Now, wave speed is equal to wavelength multiplied by frequency, which is the number of waves per second. All right, guys, that's the end for today. Why don't you go ahead, take those notes, write yourself a little summary if you like, take yourself a picture, and submit it back to Google Classroom. Hang on to those because they will give you all the answers you might need for this week's quiz.
I am Groot.